Good afternoon. We are now looking at a WebGIS tool built by the project to database historical storm events. The idea was to build up a database which could create a record of all the environmental forcing factors as well as observations, the scenarios produced by the IPCC, and also match these with observed impacts and information of any kind, including both the physical aspect as well as the economic, cultural, and environmental information. Now, Europe has a history of events which were of high impact on the population, but not only Europe. You can see in the top right-hand side the impact of Hurricane Sandy on the coast of New Jersey and New York State in the United States. Now, clearly, all of us remember immediately as large events in Europe the 1953 flood in the Netherlands, in Belgium, and the United Kingdom. But let's not forget that in France, just a few years ago, we had an event in La Faute-sur-Mer where Xynthia, an anomalous phenomenon, hit, creating death and devastation. Now, weather-related disasters have a cost to society. In a recent report by the United Nations, we have that in the last 20 years, more than 150,000 people died as a result of floods. Floods between 1995 and 2015 affected over 2 billion people, and they account for half of the losses generated by weather-related disasters. Now, we can try to discriminate between the different hazards, and you can see from these simple diagrams the weight of the flood-related losses. These are information from the United Nations database CRED. Remember that deaths are excluded from this total, so this is actually economic losses. Now, if we look at the nature of the hazard, we have to be a little bit careful because you can see that together with floods, we also have storm damage. And in reality, these two together account for almost 70% of the losses recorded between 1995 and 2015. Luckily, hazards like volcanoes are quite unusual. They can be of high impact, unfortunately, but we don't have that many in Europe, even if we do have some. Now, the nature of floods has changed in recent years, especially because we are experiencing more and more flash floods, riverine and coastal flooding more frequently. Together with these, we have the problem that urbanization has increased the flood risk, mainly because a waterproofing of the territory. If we look globally, the global databases by the United Nations identify that the 5 nations hit by the highest number of disasters are actually led by the United States and China. But let's not forget the areas where cyclones occur, like the Gulf of Bengal, where India is located, and the Far East, like the Philippines and Indonesia. Now, we should wonder, are we really vulnerable in Europe to this type of hazards? Well, indeed we are. In Europe, we have a problem. We have an intensive urbanization of the coast. You can see from this distribution of population that our population is often concentrated in large coastal towns. Unfortunately, a big one can hit us at any time, And Dutch and British people know this very well, since the night of 31st of January 1953, where a system of low pressure pushing from the east towards England with strong winds caused extensive flooding of East Anglia as well as the Netherlands. In the Netherlands, we have that this particular disaster damaged most of the dikes, flooded over 2,000 square kilometers of land, and almost killed 2,000 people, with 72,000 people evacuated. The worst disaster ever recorded in Dutch history, or not? In 2008, it financed within Framework 7 a research project called MICORE, which aimed at studying the impact of these extreme storm events. Not only the impact was studied to demonstrate real-time warning systems that for the first time were able to produce reliable predictions of the morphological impact of storm events. The project also produced a database. You can see here an example of a book produced in Italy in the Emilia-Romagna coastline about the observed storm impacts between 1946 and 2010. Unfortunately, there were a few problems with the 9 databases we developed. First of all, between sites, data collection was not consistency as databasing. This made it difficult to undertake inter-site comparisons. We could get some patterns about storm intensity age changes. You can see from this diagram published by Ciavolla and Jimenez in 2013 that in Europe there is not a consistent pattern of storm changes. In some cases, we have an increase in frequency of storms. In some cases, a change in duration. And in very few cases, a very clear signal of change in intensity. If we take, for example, the Northern Adriatic, this is data on storm surge events observed in Venice between 1923 and 2008. The line is a 10-year running mean, and you can see that indeed there is an increase observed from the 1960s onwards. But you should remember that at some stage the town was subsiding, which obviously did not help in increasing risk. Within the RISC project, we decided first of all to produce a review report of what we knew about historical storm changes, what we learned from past events, and how the different countries tackled the problem. These findings are collected together in this report, which is open source, which you can download from our website. Together with the report, we decided to build a standardized database, the RISC-KIT Storm Impact Database, which is available at this web address you find here. We decided to build the database with an architecture which was based on storing all the data in OpenEarth, the well-known Dutch system maintained by Deltares and TUD Delft, where anybody can database data, making it open. This produced a source of information which went through a database server we can visualize that can be accessed by internal and external partners. This is the way the website looks like. You can see that for each country there is a little dot with the number of database events. On the right hand side you can see the events with the location, with the date. And you can also see an icon, a little icon like the one on the top, which shows if there is, for example, images related to that. The statistics tell us that the database is very well populated for some countries, a little bit less for others. There are a number of reasons for that. For Italy, for example, there are 70 records, because in Ferrara we decided to enlarge the database to regions outside the case study site. Also notice that we have data for Bangladesh. Let's not forget that in the first part of the project we were working on the Bangladesh site of Sandwip Island too. The statistics up to July 2016 tell us of almost 300 marine events databased. The records in some occasions are very old, like the 1566 in Sweden. In other cases are pretty recent, like the one from the 1970s in Bulgaria. This is explained by historical reasons. Do not forget that in this project we are working with Professor Emmanuel Garnier, an historian, a specialist of analyzing this kind of data. You can imagine that some parts of Europe experience on the coast an earlier occupation than others, which obviously bias the amount of information available. For the database, we decided to dedicate time and effort to metadata management. It is very important for a user to know where the data is coming from. Doing so, we decided to comply with the INSPIRE directive. The OpenEarth raw data repository is stored in the server of the TARES and TUD, and it follows a standard manner of databasing this kind of information. We had to classify the information according to the impact categories, and you can see here the different categories we decided for. We spaced from population, economy, buildings, environmental damages, infrastructure, even cultural heritage if it's necessary. Doing this, we decided to use the categories which have been identified for reporting damage by the European Flood Directive. Each category has then a number of subcategories which express the importance of economical damage to a number of sectors of society. So we see here spacing from tourism to mining, agriculture, and even retail and services if we have important economic activities located on the coastline. Let's not forget about environment. These days we talk more and more about the cost of ecosystem services when hit by damage. So not only the direct impact of the event, but also the cost of erosion, oil spills that might be generated by the event, even the impact on water quality. Population is clearly the first thing you think about when you think of damage. We try to discriminate not only casualties, but also missing people, evacuation, or permanently displaced users. But also indirect damages, like for example, loss of employment in an area. Cultural heritage is becoming more and more exposed to extreme events. In some sites, it might be important to database if there are archaeological sites, if there was damage, for example, to libraries, if there was damage to buildings. Private properties are recording, including the cost of damage, cost of reconstruction, and we space from the little bar on the beach, that the one you see here, like the Meda hotel that has to shut down for a period. Infrastructure includes any kind of infrastructure, from electricity grids to water supply to hospital and schools. Where possible, we tried to collect information using media. It can be old newspapers. It can be work published by other authors, and these are normally included. Regarding images, pictures, it is very important to locate the site. So the database has a georeferencing facility where when you upload a new image, you can, using a layer on a map or a satellite image, pinpoint the location of it. So if you see here, this place on the Emilia-Romagna coast, if you click on the photograph will expand. You can easily read the name of this bar which was flooded, even the source of information it was taken from. A user might not have enough time to browse through the database, so we decided to build a facility where, for a particular event, you can easily pull up an event fact sheet which includes the physical information, the pictures available, and any other kind of metadata. The website, when you arrive, it looks like a map with a layer behind from OpenMap source. On the right-hand side, you have the list of the events. You can also search events using filters, for example, the country, the region, and bear in mind that the regions are defined by a European Commission standard using the NUTS units. You can search by year, by month, by day. You can also decide to look just at your events on the right-hand side if you are a user. And you can also decide to look only at events that have an impact. We decided to provide also some links to other databases which can be useful for a user. Information reanalysis data available from meteo centers and climatological projects. And finally, a direct link to an editor like Inspire to be sure that a user defining a new entry complies to it. And enjoy the surfing of the database.